These problems were put on this worksheet because oftentimes, if you recognize these from your last chapter of pre-calculus, they look like pieces of a limit problem. So if I were to put the limit out in front of this problem as x approaches 2, you could not evaluate that because the denominator would be 0. But there are algebraic things you can do to limit problems in order to still evaluate them. So if you see something like this one where it's got a complex fraction, we might want to try and eliminate those fractions that are in the numerator. This is called a complex fraction when you have fractions within fractions. So you would multiply by the LCD, and you'd want to do that to every single thing in the fraction. So when you do that, I'm going to work up here. You would get the x plus 2's cancel, and you're left with 4. That minus sign doesn't go away. The 4's cancel, and you're left with that quantity. Be careful there. A lot of people leave that off. Divided by x plus 2 times that quantity x minus 2. Simplifying the numerator gives you 4 minus x minus 2 over that business. Numerator simplifies to 2 minus x over x plus 2 and x minus 2. Now many of you would stop right there, but if you remembered from Algebra 2, if you pull the negative out of that numerator, it swaps those terms around, and voila, magic. I can now eliminate that denominator that I wanted to get rid of in the first place, so I could evaluate the problem if it were a limit problem, leaving negative 1 over x plus 2. Now if you were to take the limit, now you could plug in 2 and you would get negative 1/4. Now this next problem, if you notice in the numerator, it has the difference of perfect cubes. I don't know if you remember from Algebra 2, if you were to rewrite what exactly was cubed, and it was 2 cubed minus x cubed. Now you've got your bases that are being cubed, and then you would use a little trick called SOAP, which means same, opposite, always positive. So we're going to apply that technique. And if you remember how a cube factors, it's always the first term and then the same sign minus the last term without the cube on it. So I have 2 minus x. So there's the s for same. And then you would have the first term squared, which would be 4. And then in SOAP says opposite, so it would be positive. And then you have multiply those two terms together, you would get 2x. And then always positive is the last term, and you square it. And this is all over x minus 2. Now the same technique we used in part A, notice how these two binomials, this one and this one, are almost identical. So if I factor a negative 1 out of this one, it would cancel with that bottom binomial, leaving negative 1 times the quantity 4 minus 2x plus x squared. And then you could put in the 2 if you were taking the limit of that, and that would be your answer. Now this next one, say you were doing the limit, let's just play, as x approached 25 on this problem. You could not do this problem because the denominator would be 0. So what could we do to manipulate that fraction to possibly eliminate the denominator or make it something else? Anybody come up with the word conjugate? If you multiply top and bottom by the conjugate of this one. You could try the conjugate of the denominator too, but usually it's the more complex binomial over, and whatever you do the denominator, you got to do the numerator. So let's just do this algebra. If you multiply two conjugates, you just get the first term squared, which would be x, minus the last term squared, all over. And in calculus, you try and leave things in their factored form, because some of the time you get magic and things cancel, which leaves you with 1 over root x plus 5. Now if you went back to our original problem, if you were doing the limit of that as x approaches 25, you could now substitute that 25 in, whereas you could not before. Okay, this is a pretty cool problem because, but your first instinct for some of you will be to square that binomial, multiply by 4, and then see if any of the terms cancel. If you were doing a problem where the limit, craziness, the limit as delta x approaches 0, you could not do that. So let's play around with this, but your first instinct was to do what I said before, do all that algebra in the numerator and see if things canceled. However, if you notice that you've got the difference of perfect squares, there's a perfect square right there, and here's a perfect square. And you have the difference of perfect squares, which you know factors into a plus b, a minus b. So let's factor that, which would give you, you're going to need big brackets here. Square root of 4 is 2. Square root of x plus delta x squared is x plus delta x minus the square root of that last term is 2x. And then you have that same front term plus 2x. And it's still all over delta x. Now let's do some algebra in here. We've got 2x plus 2 delta x minus 2x. See some possibilities in that one. In the next brackets, I get 2x plus 2 delta x plus 2x. Nothing cool happening there, and we're still over delta x. Those 2x's cancel, and now I'm left with 2 delta x times the quantity 2x plus 2 delta x plus 2x all over delta x. And my delta x's cancel, which is what you wanted. So don't distribute until you see if things cancel. So now our final, and I'm going to turn these guys into 4x to make my life a little easier. So I have 2 times 2 delta x is 4 delta x. 2 times 4x is 8x. And now if you were doing the limit as delta x approaches 0, your answer would be 8x. Okay, on this problem we were asked to find the domain, which has to do with your x values, and the range, which has to do with your y values. Whenever you're dealing with radicals, this function, this square root of 9 minus x squared is never going to be less than 0, because you'd get imaginary numbers. You just can't take the square root of negative numbers, so that is not going to be the case. So you want to keep what's underneath that radical sign, you want to keep that greater than or equal to 0 at all times. So if we manipulate this, so now we're in Algebra 1 problem. So you have 9 is greater than or equal to x squared. Taking the square root of both sides, you get x is greater than or equal to positive 3. Less than You have to read from the left, or greater than or equal to negative 3. So this is your domain. Now for your range, for the range is when x is 0. You want to look at what your range is. So I would have y equals square root of 9, which is positive 3. So everything from 3 down is going to be your range. Actually, it's going to be less than. And it has to be less than or equal to 3. So if I were to graph this, I know from doing this that I have your domain can only be values between negative 3 and 3, and it has to be less than positive 3 on the y-axis. So if I were to square both sides on the original problem, I would get y squared equals 9 minus x squared. And hopefully you guys would all realize that that is a circle, but as soon as you take the square root of it, you only get the positive piece of the circle.